So since it's going to be on video, should we just do it every single problem? Or no?
Can we do the ones that we need first?
Huh?
Can we do the ones that we need first and then do every problem? Or are we gonna finish?
Yeah, we've got plenty of time. We're still going to finish early.
Okay.
Okay, let's just do every single problem. Limit x approaches infinity. I'm going to multiply it out. Or you can do it in your head. Well, as x approaches infinity, if the degree of the top and the bottom are the same, you just look at the coefficients 4. There, box your answer. Limit x approaches 3. Okay, so it's 0 over 0, so what do? You factor, you simplify it. These cancel out. Now can I plug in 3 and get something? 6. So you're going to have 15 to 20 of these limits. Yeah, so it's 2 points now, all or nothing. So you just make one tiny mistake. It's all over but the crying. No, you guys got to get used to that because on the AP exam, you know, the 1.1s, it's either 0 or 1. That's it. There's no partial credit. Huh? I don't know. Anyway, you plug in 2, you get negative 3 over 0. What does that mean? No, there's a vertical asymptote there. Non-zero over 0 means there's a vertical asymptote there. So the answer is either positive or negative infinity. That's the only 2 possible answers. So how do you figure out which one it is? Plug in a number very close to 2 on the right, like 2.001. 2.001 minus 5, negative. 2.001 minus 2 is positive. Negative divided by positive is negative. So the answer is negative infinity. Okay, D. Well, if I plug in 1, you get 0 over 0. What do you do when you have radicals like this? You multiply by the conjugate. Okay, but see, you guys know what to do, but you guys gotta do it correctly. You gotta do the algebra correctly. So like this. Multiply top and bottom by the conjugate of the radical expression. And then if you do that, see, when you multiply this times this, you're going to get 4x plus 5 minus 2x plus 7. Please put the parentheses. And then when you distributize that minus sign, what are you going to get? 2x minus 2? 2x minus 2. But then you can factor out a 2. And is this good? Yeah, because this x minus 1 cancels with that x minus 1. And then now can I plug in 2 and get something? Yeah, you get 2 over, and please don't forget about this. What happens when you plug in 1 here? You get 3 plus 3, which is, and that's how you get 1/3. Okay, E. Lift and separate. Whenever you see a single term in the denominator, lift and separate. So x over x is 1, and sine x over x. And is this friend? Yes, that's friend. Because x is approaching 0. So this goes to 1. 1 plus 1. We had something like that on the last quiz. And you're going to get it on the test. I don't know if you guys figured this out yet, but you know the key to doing good on the tests? What the key is? No. You do the practice test. You know, I mean, not just do it, but you got to like know it completely. So even if you, let's pretend you didn't do the homework. Even if you did badly on the homework, you can ace the test by just doing this. I don't know why I just told you that. I'm kind of stupid for doing that, but whatever. You gotta learn to play the game. Okay, limit x approaching infinity. Look at the thing in the parentheses. Oh, the degree of the top and the bottom are the same, so you look at the coefficient, so this goes to 2. So all you have to know now is cosecant inverse 2. Cosecant of what angle? So in your head, you should be thinking cosecant of what angle is 2, which means the same thing as sine of what angle is 1/2, and the answer got to be within the range, pi over 6. And since this is AB, I'll probably just give you a positive argument, yeah? Because negative, who knows what might happen. Okay, G, if I plug in 2, you get 0 over 0. So we need to factor and simplify. Okay, the bottom is easy, but the top, did you guys do synthetic division? I'm doing it right now. 1, 2, negative 5, negative 6, and you can probably guess 2 is going to work, right? Well, it's either 1 or 2, right? Because we're AB, right? 1. Do you guys figure out how this stuff? So we got x minus 2 is one factor. Anyway, to compute this limit, don't you have to cancel out x minus 2's? So the 2 gotta work, right? And then you got this. Now, do you want to factor that? X squared plus 4x plus 3, or just leave them? Okay. It really doesn't matter, that's why. So these cancel out. Now can I plug in 2 and get something? You bet your sweet bippy, if I plug in 2, you're going to get 3 times 5 over 4, which is 15/4. Ha-ga-ga! Okay, we gotta keep it on this side because that's all the camera covers. See, this is like how many times have we gone through limits? Isn't it getting easier? Okay, don't answer me. Ace, limit, h approaches 0 from the right, cosine x over x. First thing you do is plug in the number, and you get? No, 1 over 0, which means? Vertical asymptote, which means the answer is going to be either infinity or negative infinity. So all you got to do is plug in a number very close to 0 on the right, like 0.001. What is the cosine of 0.001? Think of the unit circle, like right there. Cosine in the first quadrant is positive, and 0.001 is positive. Positive over positive, positive. I. Okay, now here is the one. This is the ones I think are going to give you trouble because you got to know your base graphs. And because there's going to be like 4 of them on the test. I'll just take those 4 wrong, Mr. Park. 92 is a darn good score. That's so sad. Okay, is that a graph we're supposed to know? Now this is tangent x, not tan inverse now. Yes, tangent looks like, see, if I draw it for you, of course my dog would do it. Rough! So, what's the limit as x approaches pi over 2 from the left? Look. Infinity. So easy if you know the base graph. J. Oh, come on, man. This is an insult to my loins, this problem. So, as the graph is going out to the right, because x is approaching infinity, this is sine x, right? Is it getting closer and closer to something? No, it's just oscillating back and forth, so the limit does not exist. Can I just write this?
No.
If you have a legend, but what the heck? This year I'm just going to let you write that.
Really?
Yes, but don't write what Lamb wrote. He put LDE. But he had a legend. LDE means limit does not exist. No, but he had it on his paper, so that's fine. Limit x approaches infinity, cosine inverse of x over x squared plus 1. Okay, as x approaches infinity, what about the thing right there? If the degree of the bottom is bigger than the top, it goes to 0. So all you have to know now is cosine inverse 0. Cosine of what angle is 0, and the answer got to be in the range, pi over 2. Okay, L. Okay, 0 over 0, so we need to simplify this. Hey, this looks like a difference quotient, Mr. Park. Yeah, it does. Okay, so 0 over 0, we need to simplify this, so just multiply out the whole top. And so what do we got? 16 plus 8x plus x squared minus 16 all over x, haga haga. And then I cancel out the x's. So factor out the x, so you get 8 plus x over x. Woo! Now can I plug in 0 for x? And you get 8. M. We're flying through this. Hey, it doesn't look like today's quiz. Why am I saying that on video? Limit x approaches 0, 1 over 2 plus x. In fact, no, it's, well, whatever. Wasn't that today's? No, was it? So limit x approaches 0, so you make a least common denominator, and so don't forget the and then divide by x, and then distributize the minus sign here, and then hoga, negative 1. Now plug in 0 for x, you get negative 1/4. Okay, let's squeeze it in over here. And limit x approaches infinity 5 to the x over x to the 5. Now what happens when both the top and the bottom both go to infinity? You use EPL. So what kind of function is this? Exponential. What kind of function is that? Polynomial. Which one goes to infinity faster? Exponential, right? So if the top is growing much faster than the bottom, the limit must be infinity. And if the bottom is growing faster, then the limit will be 0. And then the last one, limit, come on! How many times have we done this limit in this class so far? Yeah, I would just say at this point, just memorize this puppy. The reason I keep giving it over and over because it comes up later on a lot. Pi over 2. Here, let me draw the graph again for the 10th time. This is what the graph of tan inverse looks like. So as you go to the right, the y coordinates are getting closer to pi over 2. Why not just memorize it already? I would. Because the probability that that being on the test is probably like 0.97. It just went up to 0.98. 0.98 or 0.98%? What? What are you talking about? I know what I'm talking about. Okay, let's just move. Piecewise function. Are we good at that now? What's a piecewise function? Okay, look. To make a piecewise function, x is greater than or equal to 0, x is less than 0, right? Because that's what makes the inside of that 0. But in this problem, x cannot be 0 because it makes the denominator 0. So get rid of that. So if the inside is positive, you leave it alone. So you just get x squared plus 2x over x. And if the inside is negative, you negate it. So it's negative x. So you get x squared plus 2x over negative x. Did you guys get that? Yeah. And then if you simplify it, you're just going to end up with x plus 2. And this one will be negative x minus 2, right? And then, does it say the graph? Yup. So the graph. These are just lines, people. So when x, if I plug 0 into here, you get 2, and the slope is 1. And if I plug 0 into that, you get negative 2, and the slope is negative 1. Okay, now answer the question. What is the limit as x approaches 0 from the left? Well, coming from the left, the graph is getting closer and closer to that point. What's the y coordinate of that point? Negative 2. B. What is the limit as x approaches 0 from the right? Well, coming from the right, the graph is getting closer and closer to that point. The y coordinate is 2. So what's the limit as x approaches 0? Well, if the left-hand limit and the right-hand limit are different, the limit does not exist. Hey, Mr. Park, this is getting easier. Okay, this looks like the one we had on the quiz today, except kicked up a notch. Yeah? Okay, so find the values of A and B so that this function is continuous. Now, this is, like today's quiz only had 2 pieces in the piecewise function. Now we got 3 pieces. Same thing. Like, these 2 pieces meet when x is negative 1, right? So if the functions, see, here's negative 1 and here's 2. So you have a line, well actually you got 2 lines. In order for the function to be continuous, they actually have to meet at that point. So if you plug in -1 for x here and -1 for x there, you gotta get the same number. So plug in -1 for x there, what do you get? 3. Plug in -1 for x here. What? I'll get 8. No, you plug in -1 over there. Negative a plus b. They have to be equal. I get 8 out of that. You got A's and B's in it. And then these two pieces meet when x is 2, right? So if I plug 2 in for x here and 2 in for x there, you gotta get the same number. So if I plug 2 into for x there, you get 2a plus b. And if you plug 2 for x there, now is the time. 8. And then you just solve these equations. And do you need help with the algebra?
No.
I think you do. Yeah, I don't know. So line them up and go, oh, I can eliminate the b's by subtracting. So if I subtract, you get 3a equal 5. Therefore, a is 5/3. And once you get a, plug it back into one of those to figure out b, yeah? Like I told you, every year, this is a problem on the AP exam. It always is. Okay, number 4. So we got another piecewise function. Oh, Mr. Park, is that why we have to learn piecewise functions in Algebra 2 and pre-calculus? Yes, because it comes up a lot in calculus. Okay, now it says graph it. Mr. Park, I hate graphing. Well, you're going to hate this test. Okay, when x is less than -2, the graph is y equal 2, so we just got like a horizontal line like that. And then what's this graph again that keeps coming up? Rhymes with hemicircle. It's a semicircle of radius 2. And then this is a line. If I plug in 2 into this, you get 0, and the slope is 1, so it looks like that. That's what this graph looks like. Are we graphing this quickly? Yeah, when I just copy you, Mr. Park, I can do it really fast. That's shameless. A. What is the limit as x approaches -2? Now here's -2. Coming from the left and coming from the right, is it going toward the same point? No. So the left-hand limit and the right-hand limit are different, so therefore the limit, Mean Girls, does not exist. Did you guys ever see Mean Girls?
He showed it.
Oh, he sent me that clip too. Okay, and then what's the limit as x approaches 2? Here's 2, coming from the left and coming from the right. Is it approaching the same point? Yes, and what is the y-coordinate of that point? 0. See how easy it is? Yeah, but Mr. Park, the hard part is drawing the graph. I told you, the hardest part about this class is the pre-calculus. Okay, number 5. F of x equals Hey, this looks like today's quiz too. Find the value of k so that this function will be continuous at x equal 2. So, what do I have to do? You compute the limit of this thing as x approaches -2. Because if you compute the limit, it's going to give you the y-coordinate of that removable discontinuity, right? And then if you just fill it in, then it becomes continuous. So we need to find the limit as x approaches -2 of that. But if you plug in -2, it's 0 over 0. So we need to simplify that. So we need to factor. How do you factor something like that? Synthetic division. So -2. What is that going to be? 1, -2, -2, 4, 1, -2, 0. So that stands for x plus 2. Of course, you're going to have that to cancel it out. And then this stuff there is x squared minus 2x plus 1. You want to factor that as x minus 1 quantity squared, or just leave it? You want to do that? I don't care. It doesn't matter. So you cancel these out. Now can I plug in -2 and get something? Yeah, probably then this one would be easier to look at, right? -2 minus 1 is -3 squared, 9. So then this must be 9, so that you fill in the puncta to make it continuous. Right? Okay, 6. Oh, now you gotta start thinking, baby. working this too far. Find the values of a, b, and c so that the limit of this function as x approaches infinity is 5. Now what does that mean to you when you see that? Skip to the next problem. No. As x approaches infinity, that means as the graph is going out to the right, the y coordinates are getting closer to 5. Doesn't that mean the horizontal asymptote is y equal 5? Okay, now how do you get a horizontal asymptote of y equal 5? What are the rules for horizontal asymptotes? If the degree of the top and the bottom are the same, then you look at the coefficients, right? So therefore a must be 5. Right? Because that's how you get a horizontal asymptote of y equal 5. So we know a is 5 now. Then it says, the limit of this function as x approaches 2 from the right. And it sounds like Julia Childs. Did you guys ever see the movie Julia? I guess not. I just saw it on TV this past weekend. You ever heard of Julia Childs? She was like a famous chef. Okay, whatever. The limit as x approaches 2 from the right is infinity. Now what does that mean? As x approaches 2 from the right, it goes to infinity. That means there's a vertical asymptote at x equal 2. Now how do you get how do you get vertical asymptotes? When the denominator is 0, right? So what would give you a vertical asymptote of x equal 2? C would have to be negative 2, right? Okay. And the final thing, that's the easy one, f of 0 equals 1. That means if I plug in 0 for x, you get 1. Okay, let's tidy this up because it looks kind of messy right now. This is what I have so far. If I plug in 0 for x, you will get 1. So 1 equals, plug in 0 for x. Oh, I forgot, this is a tuple. If I plug in 0 for x, you get b over negative 2. Therefore, b gotta be negative 2. Hey, that wasn't that hard. And then finally, number 7. So that's kind of like today's quiz, except different, yeah? Except I didn't give you a chart, I gave you an exact function. A, find the average rate of change from x equal 1 to x equal 4. How do you find average rate of change again? It's just the slope of the line connecting the 2 points. There's no calculus involved. Yeah, today's one was easier right on the quiz because I actually gave you the chart. You don't have to do any computations, but now you gotta actually compute. When x is 1, how do you find the y coordinate? You plug it in. What about 4? Plug it in, you get 64. So how do you find the average rate of change? Just compute the slope. Y minus y over x minus x. 63 over 3, cancel the 3's, 6. No, it's 21, fool! That's so stupid. Find the instantaneous rate of change of f at x. Okay, this is probably the hardest problem on the whole test for you guys, right? How do you find the instantaneous rate of change when x equals 1? You gotta do the difference quotient thing. The limit as h approaches 0, f of 1 plus h minus f of 1 all over h, right? Like today's quiz, that was nice, they didn't actually give you the formula. On the test, no formula, unless I give it to you. So, no, I have to, never mind. See, I have to judge how weak you guys are, and then I gotta adjust. Yeah. Anyway, how do you find f of 1 plus h? You substitute 1 plus h in for x, and you get 1 plus h cubed minus f of 1. You have to plug in 1 for x there, and you get, and then you divide the whole critter by. Okay, now how do you compute this limit? Because when you plug in 0 for h, you get 0 over 0. We need to simplify. Now, again, this is probably the hardest part of the whole thing. How do you expand 1 plus h cubed? Can you guys just look at it and go, 1 plus 3h plus 3h squared plus h cubed?
Yeah.
Can or no can?
Can.
Or do I have to go on the side and go 1 plus h times 1 plus h times 1 plus h?
Can.
And then when I do these two, you get 1 plus 2h plus h squared, and then you gotta times that by another 1 plus h. I don't care what you do, you gotta get that. Minus 1 all over h. The 1's cancel out. Are you guys writing limit on every step too?
Yeah.
Well, I'll check on the quiz. Factor out of h on the top. Because on the test will be minus 1 for each picometer missing of the thing. The h's cancel out. Now can I substitute 0 for h? What happens when I plug in 0 for h here and here?
0.
What?
I mean 3.
3, thank you. So that is the instantaneous rate of change. That is the slope of the tangent line right there. See, look how much work we have to do. Now, if I'm nice, see, judging by, I have to figure out how you guys are, the weakness meter, right? So if I deem you too weak, then I'll just make x squared. That's. Don't you want to be challenged? C. Write the equation of the tangent line when x is, come on, man. When x is 1, how do you figure out the y coordinate? You know, plus it's already here, yeah. 1, 1. And then how do you figure out the slope? Well, we just did, it's 3. So y minus 1, just do point slope, nobody gets hurt. That's the easiest 2 points you're ever going to get right there. D. Write the equation of the normal line. Now, what the heck is the normal line again? See here, let me show you what's going on, because some of you just like here, you need to see a visual. What does the graph of y equal x cubed look like? Does it look like this? Yeah. Now when x is 1, see, this is the tangent line, then this is the normal line. The normal line is perpendicular to the tangent line. So therefore the slope of the normal line is going to be the negative reciprocal of that. Can do? Okay, now here's the one. How many people got this on their own? 2, 3, 4, 5, 6. Okay, anyway. The reason why I put this on is because I saw it on the AP exam, so that's what happened on it. And what other point does the tangent to the curve intersect the curve? So here's the tangent line. See, here's the tangent line. It touches the graph at one point there, but if you keep going, it intersects the curve again at another point. What's that point? That's what you have to find. Well, how do you find where two graphs intersect? Yeah, you just do algebra, right? So, what's the equation of the curve? Y equal x cubed, right here, let's do it again. What's the equation of the tangent line? That was this one, right? Here, let's write them together. How do you find where these intersect? Yeah, but that's an AB term. It's called substitution. If y equals x cubed, that means I can substitute x cubed for y, right? And then you just solve this equation. How do I solve an equation like that? Well, if the power is 2 or bigger, you make one side Gino, JG, Kikaida. Like that. Okay, synthetic division. Please, every single year I get this problem and I see something like this. Every single year there's always 1 or 2 clowns. They go, oh, x squared and x. 2 and 1, minus, minus. Now some of you are going, that's right, isn't it? No! Because if you do the outside and the inside, you get negative x squared minus 2x. How the heck you get negative 3x out of that? You cannot. You have to do synthetic division. You gotta make up, you don't make up your own. So we do synthetic division, and you can probably guess 1 or 2 is gonna work. So 1. It has to be 1. Why does, okay, somebody tell me, let's see how smart you guys are. Why does 1 have to work? Because we already know it intersects at 1 already. So that has to be one of the answers, right? We don't think like that, Mr. Park. How about just put in 1 because we're AB then? 1, 1, 1. Yeah, it works! Hallelujah! So that means this thing can be factored as x minus 1, and then that stands for x squared plus x minus 2. Oh, I can factor some more. So we got x plus 2, x minus 1. Oh, but we got a double root. There's Julia Childs again. So what are your answers? X equals -2 or 1. But we already knew the graph intersected at 1. We want the other point. This one. Which one is that then? X must be -2. And how do I figure out the y coordinate? You plug it back into either this one, the tangent line, or that one, which is the curve. Which one's easier? Yeah, -2 quantity cube. There you go. And I also want you to notice something. Why do you think 1 is a double root? Look at the graph. Like when you graph polynomials, when you have an even power on it, doesn't the graph bounce off the x-axis? See, look, when you have a double root, look at the two graphs. They kind of like bounce off each other, right? Whereas this one has an odd power, that's why the graphs go through each other. Do you guys ever notice things like that? No. Hey, Mr. Park, I think this test is doable. Yes. The key is this. Now, maybe this one was a little bit difficult, but then when you do the second one, unless you do the second one first, then the first one will be easier then, if you did the second one first. Okay, so everybody knows, okay, so this is what's going to happen now since we got these dumb double periods. I shouldn't use the word since it's being recorded. I shouldn't call them dumb. These stupid double periods. So, wait, your period what?
3.
3. So I see you tomorrow. So this is what we're gonna, and then the other class I see them on Monday and we have the test Tuesday. Okay, so we're gonna go over, I'm gonna pass back the quiz, we're gonna go over the second worksheet, and then since we have a double period, do we have a double period?
Yeah. Well, I mean, it's 85 minutes.
No, it's not. It's only 55 minutes.
Not
Oh, but when you take the test, no, those aren't double periods either. Oh, okay, we don't need to worry, there's no double periods. So. Because if it was a double period, then we would have to learn the next section. But that's not going to happen. You guys already had your double period on yesterday. Is that correct?
Yeah.
Okay, so no need worry. No worries, mate. All right, this class ends at 9:10, so you got 9 minutes left.